Hello, this is Mike Oliver with another service-oriented architecture concept briefing. SOA means agility. Agility is one of the main justifications for moving to a service-oriented architecture. Let's review some of the other concepts. So here's a point-to-point example. We have an application. It needs to talk to another application, and so forth. It has several different application APIs that it needs to access. So in this case, this application needs some piece of information here, so we write an integration. Then it needs to talk to this application and gets some information. Then it does some processing and it needs to write something to this application, gets a response back, and then goes to this fourth one. Now, this is a very common model. This is the way most systems were built up, but in large organizations where you may have many applications talking to each other, it quickly gets out of hand, and it's brittle. If you make a change here, you may have to change all four of these. So it really becomes a nightmare. So as the organization grows, we get more and more applications talking to other applications via their APIs, and eventually we get more integrations than we have applications. And this doesn't even consider the fact that this application may need to talk to these three as well. This is just across the board. So in some cases, you'll have one little piece in here that breaks, and then you're trying to figure out where the fault comes. It's not in here, although it may report that it's in here. It's in this one little line going across there. So that's not very agile. Let's look at a SOA example. Now, you've heard me before say that having an ESB does not give you SOA, and just because you have SOA doesn't mean you have to have an ESB. But for the sake of this example, I'm going to use an ESB here, but it could be any message-oriented middleware. It could also be just plain way of accessing these via REST or SOAP or whatever, and not even use an ESB. But this example is about the agility you get from service-oriented architecture. So let's take that same example from point to point. The same 8 applications, and we hook each of those application APIs to the ESB. And we do that through a standardized service contract that includes a canonical schema that includes all of the data elements for all of these applications. So if I send a message requesting data from any one of these, it'll be the same canonical schema, the same standardized service contract, and the app or the adapter to that app knows where to get its data in the schema, where to put its data before it returns it back to the ESB. So let's take a look at why this makes it more agile. Let's take this application A, and we have a service registry. And the service registry is where we store all of the endpoints for all of the application flows that we might have. So application A raises an event to the ESB. It looks up a service registry and says, what are the endpoints that I need to traverse? And the registry comes back and says, oh, you need to go to B, then C, then E, then G. So A then says, okay, I'll send the first one to B, and B knows where to get its data and where to put its data. It comes back to the ESB, and then it goes to C. C knows where to get its data, where to put its data, and it comes back to the ESB. It then goes down to E, and E knows where to get its data, where to put its data, and it goes back to the ESB. Finally, it goes to G. It knows where to get its data, put its data, and it comes back to A, and the process is complete. So that's obviously good because B can talk to C and E and F and H and and D can talk to B and D, and everything works just fine. So the agility comes from taking that same model and saying, I'm going to change the flow for this event from A, and I'm going to do it so that it goes from B to C to E and then F that I left out before, but that adds some value. Maybe it's a logging application, or maybe it's some sort of monitor or dashboard collector, and then go to G. So now the same event, in just moments after I save this, that event happens and it goes first to B, then to C, then to E, then to F, which it wasn't going to before, but still F knows where to get its data, where to put its data, and then to G before coming back. Now, what you have effectively done is created a new application, and that new application includes F that it didn't have before. Imagine going back to that point-to-point integration and saying, well, I need to change this, I need to add that, I need to adapt to this API, and guess what? I need to change my orchestration application because I need to add F into that flow. Plus, I need to do a regressive test, I need to do all of those things. Guess what? SOA enables you to change the flow of an application from one atomic service to another and from composite services to another without any code changes. I don't have to change any code. All I have to do is go to the registry and change the response to a request from A that says, where do I go for this event? Now that is agility. And that can be done while you're in production, while your customers are all processing their requests, and you never have to have any system downtime. So it's a very good thing to have. And that is the whole enchilada from agility for an ESB and SOA. And a reminder, you don't have to have an ESB to have SOA, and having an ESB doesn't mean you have SOA, and conversely, you can have SOA without an ESB, and this is just a demonstration of the agility you get when you combine the two. Thank you very much. See you on the next concept brief.